All right, guys. So we are back from the interruption as usual. So as I was saying, we would pair these four terms into two what we call binomials. So this would be one pair of binomial. This is another pair of binomial. And so what we're going to do, each of these binomial, we're going to factorize them. So for this binomial, the common factor, the first one, which is ax plus ay, the common factor here would be a. So we pull out our a as our common factor for the first pair. After we have done that, we're going to open our brackets. Sorry for the poor writing, guys. I don't know, sometimes this thing works well, sometimes it doesn't. All right, so a, then we divide each of these terms by a. So a cancel with a, leave x for the first term. And a cancel with a in the second term, leave y. So it means that we would have factorized that first pair. And then now, keeping the plus sign in between them, we factorize the next pair. And the common factor for the next pair would be b. Pull out the b. And divide each term by b now. So we have b into bx, give you just x. Plus b into by, give you y. Now, after we have reached this stage, we are not yet finished. This step now, we now need to look at the brackets. Now, when you look at the brackets here, for the second stage, for this stage here, we look at the brackets. We look at the expression in the brackets. Now, the expression in the bracket will, if you factorize it correctly, these expressions will be exactly the same in the brackets. So the first pair, you would have a bracket x plus y. The second pair, you'd have b bracket x plus y. So here we notice that the brackets would have the same expression in them. And because they have the same expression in them, we're going to treat the entire bracket as a common factor. So it means then all of this expression here can be further factorized using the brackets as the common factor for these two terms. So we pull out the brackets. So the bracket is what? X plus y. So that's the expression we have in the bracket. X plus y. And now we're going to factorize by the bracket. So what we're going to do, this term, we're going to divide it by the x plus y. So we're treating the bracket like a single term, right? Because once we have brackets, you treat the entire expression just like a single letter. So if you divide bracket x plus y, if you divide a bracket x plus y by x plus y, you notice that the x plus y will cancel out with the x plus y here. So this here, the x plus y that we have here would be our HCF. So this x plus y that we have there would be our HCF. So this is our HCF. Now we want to use the HCF now to divide each of these terms up here. So for the first term, we have A x plus y. So we divide x plus y into x plus y, that cancel, leaving A. So we put back the plus sign that we have in the middle. And then now we divide B x plus y by x plus y. We have remaining B. Now, oftentimes, students kind of think of this in a very simple way, rather than thinking that you're actually finding the HCF. What some students would generally do, they would say, all right, you look at the two brackets here. If they're identical, what we do, we just pull out one, and then what is outside the bracket, which is the A and the B, we just put those in the other bracket. So that's kind of a simplistic way of looking at it. But just to let you know that this process is still factorizing. And so when we're factorizing, we have to have a HCF. So this entire expression, the HCF now, would be x plus y. So we're treating it in the same respect as how we did all the other factorization. All right, so we end up now with a result of bracket x plus y times bracket a plus b. And so this becomes a binomial product, right? Now, if you really want to check to see if your factors are correct, you simply expand these binomial, which you would have already learned how to do. So you expand the binomial and you should end up back with what you started off with. If you expand them and you don't get back what you started off with, it means chances are you would have done something wrong. So you'd have to go back through the steps to see where you would have gone wrong and make that correction. So let us expand these and see whether or not we get back the entire expression up here. So we have x times a. If you write your product in alphabetical order, then you will get ax for the first term. All right, so that's when we multiply these two together. Now we use the x now times b. And so we will get bx. Then we're now going to expand using the y. So we have y times a, you get ay, and then y times b, you get by. Now, the order that we get the product in terms of these terms, the order really doesn't affect the results. But once you have the same exact terms in the product from as what we started off with in the expression, once you have the same exact terms, so up here we have an ax, down here we have an ax, we have an ay here, down here we have an ay, we have a bx up here, down here we have a bx as well, we have a by, down here we have a by. So once you have all of these terms that you have in the original expression, then you know your factorization would have been correct. So our factors are, so this, what I did here just now by expanding the brackets, that is only to check to see if your factors are correct. But your answer should be the product of x plus y times a plus b. So this is the actual answer that we have here. I hope everybody's following, and I hope you're understanding that. So let me see the hands if you are following so far and you understand what I've just done. All right. All right, so let us continue to see, can do some other examples. All right, so based on what we have just done, we can look at it in a step-by-step process. So the first step, you want to group the terms in pairs so that each pair of term has common factors. So in other words, you can identify HCF for each pair. Now, once you have done that, we notice that by pairing them, we have AX and AY. We group those together because we have a common factor A. We group the BX, BY together, so we have a common factor B. Second step, we factorize each of these groups. We get the A bracket X plus Y, then B bracket X plus Y. The X plus Y is common, so we further factorize by the X plus Y as the HCF. And so by pulling out the X plus Y as the HCF, we divide each of these by X plus Y. The first term we get is A in the second bracket plus B in the second bracket. And so that would have given our answer. So here we have now a second example. And so let me just quickly go through this one with you. And so in a similar way, we're going to look at the pairs that we have. Now, there are times when the arrangement of these pairs may not necessarily adequate enough for you to identify a common factor. When that is so, you need to try rearrange the terms in the expression to see if you can pair them up with some other terms so that you can actually get common factors for each pair. So that's one thing that you need to consider when you're factorizing these four terms. All right, so the first pair, we notice that we have a common factor, which is P. So we need not rearrange that pair. The second pair, we have a common factor. And we notice that the common factor Q, both of them carries a minus. So we may want to use that minus Q instead of just Q as the common factor. So for the first pair, our common factor is P. Pull out the P. And when I use the term common factor here, I'm referring to the HCF. So P into NP, P cancel leave N, P into MP, P cancel leaves M. So next, for the next pair, the common factor would be minus Q. And so minus Q, now you have to take into consideration that you're working with a negative sign. So if you're dividing a negative by a negative, the result going to become positive. So bear that in mind. So here we have negative Q divided into negative Qn. Negative Q divided by negative Q give you positive 1. So you only have N remaining for the first term for this bracket. All right, so the second term will be, so we have negative Q into negative QM. negative Q cancel out will give you a positive. So you have positive M. Now we close our brackets. And after we have done that now, we look at the two bracketed expressions. Now, these two expressions, you want to check them before you go any further. You want to check and to ensure that these two expressions are exactly the same. If they are not exactly the same, it means that you either need to go back from the top and either rearrange the terms and start over with the factorization process. So whenever you get to the second step, the two bracketed expressions are the same. So once they are the same, then you will continue on by choosing the one of the bracket now as the HCF because they are common. So we will pull out N plus M as our common factor. And now we would divide each of these terms. So P bracket M plus N, when you divide that by M plus N, it cancels. So in our bracket here, we would have P. And as I said before, once you pull out the one of the brackets up here, which is N plus M, the other two letters outside, you can just group them in the other bracket, keeping the sign in the middle. So you would have P minus Q. All right, so that would be the result after you factorize by, so you would have the P M plus N cancel with the N plus M, then the Q negative Q N plus N cancel with the N plus M, leaving Q. So that would be your factors. Or those would be your factors. The factors here would be N plus M and P minus Q. All right. Everybody is good with that? Let me see your hands if you are following so far. All right, so far, some persons are showing their hands. All right, so just to go back through that once more. So you pair your 4 terms into two terms expression or into binomials. Then from the binomials, you pick out your common factors and factorize each pair by their common factor. And here, for the first one, we would have P bracket M plus N. When we factorize that first pair, second pair, when we factorize, we get minus Q plus bracket N plus M. And then now by further factorizing by the M plus N, N plus M, we will have the factors N plus M times P minus Q. Here we have some questions now. Let us see what time we have. I think we can start doing these and see how far we get before the time runs out. So I'll just give you some time to do this. So go ahead now, guys, start these questions and let us see if we are able to finish them before the time runs out. All right, guys, so I'm back. Now, let us see if we can quickly go through this exercise in the interest of time. So for question 1, what we notice here is that the order in which the terms are in for question 1, they actually don't offer, if you pair them like that, they don't offer any common factor. So what you really need to do in that case is to reorder them so that you can find pairs with common factors. So here we could group the AX with the BX. So that would give us R if you want to make the A common. So in this case, if you want to make the X common, you group AX with BX. If you want to make the A common, instead you could group AX with AY so that you make the A common. All right, so whichever way would actually give you an option to pair them with common factors. So let us go AX with BX. So we would reorder it. So we write AX plus BX. So AX plus BX then now we would group AY with BY, so plus AY with BY. All right, so for each pair now, we look for the common factor. Over here, X will be common. For the first pair, the X will be common. So we factorize by using X as our common factor. So here we have A plus B in this bracket, close. Then now we have the Y being common. So we would have A plus B in the second bracket also, which we are expecting to happen. So if we don't have these two expressions the same, that means we need to go back and check the original expression. All right, so here we have the bracket is common, so we pull out A plus B. As our HCF, then we divide each term. For the first term, we get X, and for the second term, we get Y. So those would give us our common factor for the, those would be the factors for our first question. Let me see the answer, those who got those. All right. All right, moving on. So question 2, well, this question 2 looks similar to the one that we would have done in the example. So if we do that one, I think, is it okay to skip question 2, guys, since we would have pretty much done that one in the second example? Let me see the answer, those who like to go, let me see the answer, those who would okay with us moving on to question 3 instead of doing question 2. All right, good. All right, so going on to question 3. Now we can look at the pairs that we have and see whether or not we would be able to find common factors as is. And here we would have AC common. For this one, we would have, instead we would have D common. So possibly we could have the same arrangement and factorize it just the same. All right, so let us try doing that. So we have A squared C squared plus ACD plus ACD again plus D squared. Now, you could probably rearrange it differently and still work out to get the answer. But let us see if this arrangement is okay. All right, so for this first pair, the common factor would be AC. So we pick out AC as our common factor. So AC into A square, C square would just give you back AC. Now over here now, for the next term, AC into ACD will leave you only with D. Those are brackets. For the next term, our common factor here would be what?
Yes, sir.
No, our common factor would be D. I forget this square on this D here. So our common factor would be D. So we pick out D as our common factor. So D into ACD will just leave AC. And D into D square would leave D. When we check the expression now in the brackets, we notice that the expression in the brackets are exactly the same, so we can pull out the brackets. So we have AC plus D common. And then now when we divide each term, for the first term, we're going to get AC for the second term, we're going to get D. So for the second bracket, we have AC plus D. Now both brackets have AC plus D. So it means that you're multiplying AC plus D by itself. So we could write it as a square. So we can write it AC plus D bracket all square. All right, let me see the answer, those who got that one.
Sir, question.
Yes.
In the original expression, what you have, ACD or is that ACD?
In the original expression,
Yes, to the end part where you have D
is
squared.
ACD
Okay, okay, right.
ACD in both cases. There is a ACD here. All right, any other question? All right, let me see the hands of those who finish these questions. We'll actually finish them. All right, now our time is already expired. I don't want to rush through these. So we would have been up to question 3. So what I'm going to do, I'm going to leave the remaining questions so that when we get back next class, we can pick up from there. All right. So, all right, I'm going to stop right here and pick up from this point next class, guys. All right.